Hello. We're going to begin a new unit dealing with counting atoms. Some of this information you have already covered. Later on in the presentation is stuff that we were going to be introducing that we will need in order to balance equations going forward. So let's begin. As we will review the rules for counting atoms, is that the subscripts only refer to the atom that they are behind. For example, H2S. The subscript of 2 is only modifying the hydrogen. That subscript is only referring to the hydrogen atom, and it indicates that there are 2 atoms of hydrogen. The unwritten subscript behind the sulfur is 1, and hence we only have 1 atom of sulfur. If an element or compounds are inside of a parenthesis, then the subscript behind the parentheses applies to everything inside. We see Ba parenthesis OH subscript of 2. Because the subscript of 2 is on the outside of the parenthesis, that element or that subscript of 2 applies to both elements that are inside of the subscript or the parentheses. The easiest way to remember is that our unwritten subscript is always 1. In order to determine how many atoms of both the O and the H that we have is to remember that the subscripts indicate how many of those substances we have. The subscript of 2 tells me that I have 2 polyatomic ions of OH. This subscript can also be determined by taking the exterior subscript of 2 and multiplying it by the interior subscript of 1. The breakdown is that I have 2 oxygen atoms and 2 hydrogen atoms. But as just mentioned, if I am multiplying my subscripts, I have 2 times 1 for my oxygen, and I have 2 times 1 for my hydrogen. My exterior subscript is multiplied by the interior. So as I count out my atoms, I have 1 barium, 2 hydrogen, and 2 oxygen. Now the introduction of a coefficient is that, similar to algebra, the coefficient applies to an entire variable. In chemistry, it applies to the entire molecule. So when we have coefficients, we have to remember that we are multiplying them by everything. Let's take a look at an example. I have a coefficient of 2 that applies to the entire molecule of H2S. From our first slide, we determined that there were 2 hydrogen atoms and 1 sulfur atom. But because I actually have 2 of those molecules, the 2 is multiplied by both of the subscripts. I have 2 times 2. Likewise, my unwritten subscript of 1 for my sulfur means that I have 2 times 1. That will also tell me the number of atoms that I have in this particular molecule. For hydrogen, I have 2 times 2. That will result in 4 atoms of hydrogen. My 2 times my subscript of 1 means that I have 2 atoms of sulfur. Remember that any element that does not have a subscript behind it, there is only 1 atom of that element. It's the unwritten number 1. Let's practice. I see MgCl2. I first want to identify my elements in my compound, magnesium and chlorine. I have an unwritten subscript of 1 for magnesium, which indicates that I have just 1 atom of magnesium. My subscript of 2 means that I have 2 atoms of chlorine. Pretty straightforward. For my next compound, I'm looking at Al2S3. I want to identify my elements, aluminum and sulfur, and then analyze the subscripts to indicate how many atoms of each. I have 2 atoms of aluminum and 3 atoms of sulfur. H2SO4. Again, the very first thing I want to identify are my elements that are in my molecule. H2 means that I have hydrogen, S means that I have sulfur, and O means I have oxygen. My subscripts indicate what my number of atoms are. I have a subscript of 2 for hydrogen, meaning 2 atoms. A subscript of 1, it is unwritten, for my sulfur, and a subscript of 4 for my oxygen. My next molecule, CH3OH. Again, I want to define my elements that are first indicated in my molecule. I have carbon, hydrogen, and oxygen. I want to analyze their subscripts and combine the total number of atoms in that molecule. For carbon, the unwritten subscript is 1, and I have no other atoms in that molecule. So I identify 1 atom of carbon. Next, I see an H3 for my first part of my molecule. But then I also see an H with a subscript of 1 in my back. 3 plus 1 equals 4. Because I am looking for the total number of atoms in my molecule, I must take into consideration both of those values. 3 plus 1 is 4. I look at my oxygen. A subscript of 1 means I only have 1 atom. Let's take a look at those with parentheses. Again, when I look at a molecule and I'm trying to determine the number of atoms, I first must identify the elements that are in that molecule. Calcium, phosphorus, and oxygen. So now let's take a look at my subscript. Because I have my parenthesis and a subscript here, let's focus on the first portion of my molecule, calcium. I have a subscript of 3 that only applies to that calcium. So the number of atoms in calcium are 3. My polyatomic ion in the back, I have a parenthesis, an exterior number of 2. What that is indicating is that my entire molecule, PO4, is that I have 2 of those polyatomic ions. And since we are trying to capture the entire number of atoms in there, I must look at the subscripts for each of those atoms. I have 2 phosphorus, and I have 8 oxygen. Again, my subscript lets me know that I have 2 of these. Now, in order to work on my shortcut, what I actually want to look at is being able to take my exterior subscript and multiply it by each of the interior subscripts. So for my phosphorus, I have a subscript of 1, and I want to multiply it by the exterior subscript of 2, so I have P sub 2. For my oxygen, I have an interior subscript of 4 and an exterior subscript of 2, so I want to make sure that I have O sub 8, clearly defining that I have 2 phosphorus and 8 oxygen. Let's continue with the next. Al2SO4 3. Again, first identify our elements. I have aluminum, sulfur, and oxygen. Again, let's focus on the first half of this molecule that is not in parentheses. And I clearly see that I have 2 atoms of aluminum. If there's no parentheses, I can clearly define that. Now let's take a look at my polyatomic ion in the back. This exterior subscript of 3 means that I have 3 polyatomic ions of SO4. Well, I can break it down and look at that. If I add my subscripts, I have S3O12. But understanding the subscripts can be multiplied by each other. My exterior subscript multiplied by my 1. So my exterior subscript of 3 multiplied by my interior subscript of 1 means that I have 3 sulfur. My exterior subscript of 3 multiplied by my interior subscript of 4 means that I have oxygen 12. Either way, we can clearly identify the number of atoms in our polyatomic parenthesis. 3 sulfur, 12 oxygen. Now the idea of coefficients. Much like in algebra, the coefficient is applied to the entire variable. When we multiply by a coefficient in chemistry, we multiply by the entire molecule. So the coefficient of 12 means that the entire molecule is multiplied by 12. I have 12 sodium atoms and 12 bromine atoms. The breakdown really means that I have 12 sodiums and 12 bromine. This is the breakdown. I don't expect you to have to write that. What I want you to start recognizing is that the coefficient of 12 multiplied by the subscript of 1 means that I have a 12 times 1. My coefficient times my subscript means that I have 12 atoms of sodium. And likewise, when I have my coefficient and I multiply it by my subscript, I have 12 times 1, resulting in 12 atoms of bromine. If I were to count all of these individual bromines up, I do indeed get 12. If I count all of these individual sodiums up, I also get 12 sodium. I identify my elements, and I identify the number of atoms for each of those. Let's take a look at our next. I have 7 C2S2 molecules. Much like before, the coefficient of 7 means that the entire molecule is multiplied by 7. I can break it down into 7 times calcium subscript 2, carbon subscript 2, and 7s2 sulfur 2. What this means is that I have 7 C2 groupings, and likewise 7 S2 groupings. So I identify my carbon and sulfur as my elements. This is the breakdown of what this means, is that I have 7 groups of C2 and 7 groups of S2. My shortcut means that I will take my coefficient and multiply it by my subscript. Carbon equals 7 times 2, 14. Likewise, when I go to look at my additional elements, I also take my coefficient and multiply it by its subscript, sulfur, 7 times 2. For each of these circumstances, I am able to determine the number of atoms based on its coefficient and its subscript. This is what's happening in the background. This is what's happening in the background for each of these elements. I don't always want to have to write my C2 plus C2 out. I want you to understand that's what's happening, and that's how we can derive our 14 atoms of carbon and our 14 atoms of sulfur. Let's take a look at the next. For K2CO3, each of these elements must be multiplied by the coefficient of 4. The coefficient of 4 will be taken in to all of these elements. If I were to break it down, I see that I have 4 K2s, 4 carbons, and 4 oxygen sub-3s. If I were to break it down and show you what's going on in the background, this is what's happening in the background. I am able to look at my subscripts in order to figure out what my total number of atoms are. Again, I don't want to get into a habit of writing this down every time unless I need to. I want to be able to look at my coefficient and multiply it by each of its subscripts. So I have, for potassium, I have 4 times 2 equals 8. For my carbon, I have 4 times 1 equals 4. And for my oxygen, I have a subscript of 4 times the subscript of 3 equals 12. Again, my coefficient is 4. multiplied by the 2, 1, and 3 subscripts in my molecule. Let's continue on. Let's practice another. Now I see a coefficient of a molecule with parentheses and a subscript. Let's continue to see how this breaks down. Again, my coefficient is 2, which means I multiply the entire molecule by 2. I break it down into the parentheses and its independent element. My first polyatomic ion is broken down, and I see that I have 2 groups of NH4 sub 3, 2 of those polyatomic ions. Now my subscript of 3 means that I want to be able to take in this element or this polyatomic ion that many times. So I look at it and I break it down into NH4, and there are 3 groups of them. I continue because I want to be able to demonstrate that they are the subscript multiplied by the subscript. So I take N1H4 and know that for 3 of those, I have the 1 times the 3 and the 4 times the 3. So the nitrogen is 1 times 3, and the hydrogen becomes 4 times 3. Nitrogen results in 3 atoms. My hydrogen results in 12 atoms. That is for each of those independent groups. I have N3H12 in my first grouping, but remember my coefficient says that I have 2 of those groupings, and I have an N3H12 in my second grouping. Again, I took my exterior subscript, I multiply the interior, N3H12, and because I have a coefficient of 2, I have 2 groups. Now, when I go to count my nitrogens, I must not forget that I have 2 independent nitrogens that are separate from the original polyatomic ammonium. As a result, I have 6 plus 2 equaling 8 nitrogen, and my hydrogen is 12 plus 12. As a result, I have 8 nitrogen and 24 hydrogen. For my additional problems, let's take a look at 4Al parenthesis OH subscript 3. I want to be able to identify again 4 molecules, and one of those is a polyatomic OH3 molecule within it. As I break it down, I can break it down into its first element, aluminum, and that as a subscript of 1, I end up having 4 times the subscript of 1, which means that I have 4 aluminum elements or atoms. As I break down my 4 times my polyatomic ion, this makes it that I have 4 groups of OH3. As I remember, my exterior subscript is multiplied to each of the interior subscripts. So I have 3 times 1 for both my oxygen and 3 times 1 for my hydrogen. That results in an O3H3 molecule 4 different times. Again, my 4 is based on my quantity of my coefficient. So now as I go to gather all of my elements, I identify my elements and count up the number of atoms that I have. I have aluminum that are 4. I have oxygen, which are 3, 6, 9, 12. And I have 3, 6, 9, 12 hydrogen. Lastly, let's take a look at Ca3PO4 subscript 2. Again, 2 is being multiplied by the entire molecule. But let's break down what the molecule is. Again, I see that I have calcium in my first portion of my molecule. I can separate that from the additional polyatomic molecule PO4. So we break it down into its 2 separate components. I have calcium, but I have Ca3, calcium 3. That means in each group of 3, I have 2 groups of 3. For my polyatomic ion, I have 2 groups of PO4 sub 2. This molecule, or this exterior subscript, means that I have 2 of the interior relationship and atoms that are part of my larger molecule. I can multiply my subscript of 2 from the outside into the interior. What that really breaks down is that I have 2 times 1, 2 groups of 1, and 2 groups of 4. And with my second one, 2 groups of 1 and 2 groups of 4. When I go to calculate the shortcut for this, I want to identify that my exterior subscript is multiplied by the interior subscripts. The interior subscript of my phosphorus is 1, and I multiply it by my exterior subscript of 2. This gives me the phosphorus with a subscript of 2. Now I look at my oxygen. It has an interior subscript of 4 and an exterior subscript of 2. This means that my oxygen has a subscript of 8. When I multiply my 2 times this polyatomic ion, I now have P2O8, and I have 2 of them. That results in a P4O16 number of atoms. Because remember, multiplication is adding. When I take my coefficient and multiply it by my subscript, I get the total number of atoms. When I take my subscript or my coefficient of 2 and multiply it by my subscript of 8 atoms for my oxygen, 2 times 8 is 16. I get 16 atoms. Now I look back and I count up my number of calciums. Again, this is what it looks like in a breakdown. And I have 6 calcium. The shortcut means that I take my coefficient and I multiply it by its subscript. 2 times 3 equals 6. My coefficient times my subscript means that I have 6 calcium atoms. Thank you.